So hello, everyone. Welcome to the Forensic and National Security Sciences Institute. Today we are, thank you for joining us. We're kind of giving you an example, a mock class of what one of our classes might be like. My name is Kathy Corrado. I am director of the Forensic Science program here. I've been here about 2 years. Prior to coming here to the university, Syracuse University, I was the crime laboratory director for the Onondaga County Center for Forensic Sciences. And that is here in Syracuse, New York. It's the county crime lab. We were a full service lab. My background is in forensic DNA analysis, but I oversaw firearms, latent prints, drug chemistry, digital evidence, and arson. And today you're going to hear from one of our professors. David Tate is actually a latent print examiner that works at the county crime lab here in Syracuse. So he was one of the people that worked with me in the lab. And he is also a professor here in our program where he teaches some of our latent print classes. So I think with that introduction, Dave, I will just let you take over.
Thank you, Doc. Welcome, everybody. I'll start by introducing myself in just a second, but I'll let you know how this is going to go. It should be roughly a half hour in length. It's going to be a real quick, brief, dirty intro about what fingerprints or latent prints actually are. And then we're going to do a lot of poll questions where I'm going to ask you to choose a response. And you'll see how much knowledge that you have that's either correct or incorrect. And even if you don't know, try to make your best educated guess. Just have fun with it, and we'll see how much that you actually know as far as what's real and what's not about what latent prints are. Because there does seem to be, which is the case with a lot of sciences or forensic sciences, especially, some misconceptions. Sometimes things are totally blatantly false, and sometimes they're somewhere in between, and there's a lot of nuance to be fleshed out. So we'll see how this works, and sit back, enjoy, and at the end, or actually if at any time, if you want to unmute yourself and ask a question, I'm open to that too. You feel free. It's not really what I consider an interruption. If you ask a question, I would love to field the question, or we could wait to the end too if you're more comfortable just holding up to the end. Either way, I'm here to answer your questions if you have them. And there's my contact info up there. So if you want to get in touch with me after this, you feel free to do so. All right, here we go. All right, so as Dr. Corrado said, I'm Dave Tate. I'm a adjunct professor here, as well as a full-time latent print examiner. I've been a latent print examiner for over a decade and a half in this area. So I have a bit of experience and knowledge with this discipline. In fact, probably fairly specifically so. We're going to have some fun with it. There's a bit of a theme here. It'll be pretty easy to guess what the theme is. If you haven't already guessed from that title slide what the theme is, you're definitely going to know within a few slides. So I'm a bit of a nerd when it comes to this, but I hope you enjoy it. So we're going to talk about general evidence and crime scene recovery and prints and what a latent print actually is. So we have to first think about the skin of your hands. Technically, your feet are included in this as well, but generally we think of the friction-rich skin of the hands coming into contact with an object or a surface. And so we're going to talk sometimes about skin and what the friction-rich skin of the hands looks like, what it is, how it contributes to fingerprints, aka latent prints, as it pertains to evidence and crime scene evidence. So on those many ridges that you have on not just your hands but your feet as well, you have ridges, you have furrows, which is a space between ridges, and you have sweat pores that align all along those ridges. Those pores sweat constantly throughout the day, sometimes a lot, sometimes very little. Some of this can be induced through emotional situations. Perhaps if you're going to a job interview or taking a test, you might sweat a little bit more. Some people naturally have more of this than others, but everybody does to some extent sweat through the friction ridges. And you have a very high density of these sweat glands on your hands and feet compared to other parts of the body. And this contributes quite a bit to leaving a fingerprint behind on evidence. And so here's a good example. You have some prints that you can actually see with just illumination with a high intensity flashlight. And that's technically a latent print. If you can't see it with the naked eye, and it requires some type of processing method, be it chemical or illumination, that's lumped into the term latent print, something that's not able to be seen. And then what you do with those prints afterwards is sometimes develop it if you need to see it better to preserve it. And then you get a record where you can record whether it's ink or live scan. And some of you out there, this is a large group, so some of you may have had fingerprints taken for one reason or another. And you have a deliberately recorded set of exemplars or a standard in which to compare that latent print to hopefully make an identification, which will aid in an investigation, be it to exonerate or exclude an individual from being the source of an impression, or to include or identify them as the source of the impression, and all the ramifications that come along with that type of decision sometimes are pretty consequential. All right, so that was in a nutshell what latent prints are. We're going to start our first poll question here. And if I got this in order, let's see how this works. All right, go ahead. Okay, a couple more seconds. Excellent. So most of you got it correct. It's the middle one. Some similarities, but they are different. So do twins have the same fingerprints? If you look at these prints, top and bottom, they are from different people. They are from identical twins. And if you look at just broad patterns, which is class characteristics, in other words, group characteristics, things that you share and I share, just like we have 2 eyes, 2 ears, 1 nose, 10 fingers, and things of that nature. You could share different class characteristics, pattern types. I don't think we're surprised about that. And we're not surprised that twins have very shared class characteristics many times, but not all the time, which is also interesting to note. And if you look at the red lines with the little boxes around them and the blue lines with the boxes around them, these are just plots, and they show locations of where a ridge ends or splits, and also shows the direction in which it does that. And if you look at just an overall view, you can see that there is a bit of similarity, but this is probably the same similarity you'd see in just a generalized search of a population of a normal population set. But if you look at just a handful, 5 to 10 of these features in a given location and compare it, they are going to be somewhat different. And that's within the best case scenario of 2 individuals who share the same genetic code or DNA, which is as good as you're going to get. Now, that's an mostly entirely rolled, deliberate standard fingerprint. So that even with that, we see similarities, but we see differences. Now, if you get into casework prints, and this is a case also of identical twins. Now, this is a very famous one. This goes back to a proficiency test in 1996, where they were fingerprints of twins included and a partial impression, as you see here, which is a lot more representative of a typical latent print from a crime scene. And this one happens to be a bloody print, which is not without its own issues to begin with. But if you were to look between the left print and the right print and try to make this decision, well, this was a print that, because of the high similar nature of twins' fingerprints in certain regions and a lack of clarity and the overall quality of the print that you're comparing, a lot of people got this wrong. And so it's one thing to think about, do twins have the same fingerprints, but it's a whole other ballgame to think about whether or not a partial print left behind, whether it's a twin or someone totally unrelated, could share enough degree of similarity so as you can make a mistake and attributing that print to one person or another. And so that's really where latent print training and the discipline focuses on how to figure these things out. All right, next poll question. Okay, a couple more seconds. This is a very interesting spread of results, and no one chose race or ethnicity, which is interesting considering it's a I'd say a group or class characteristic, much like the other two answers that some people did choose. Well, the correct answer technically would be none of the above, but this is one where there's a bit of a gray area and we should explore it a little bit. Okay, so among other things, you can sometimes look at the age of, or predict, although very inaccurately, the age of someone just by the size of the impression. So in other words, a child's fingerprint versus an adult's fingerprint just by the size characteristic alone, you can make a pretty good determination that you're going to be right, you know, probably 95% of the time. And so that is an age-based thing that you can make a judgment on. And one of the reasons, though, that we have a hard time doing this with fingerprints as far as determining age, sex, ethnicities, and so on, are the fact that there's way more degrees of similarity between humans than there are in the variations. And this has to do because largely we all have a shared genetic situation, and our developmental conditions are largely going to be the same. You know, the variation in developmental embryology and fetal development is so similar among our species, is what makes us a species, of course, but it's the reason that we have a lot of features that we can share together. Probably didn't say it as eloquently as I'd like, but if you've ever heard of any fingerprint patterns, loops, whorls, and arches being the three main ones, it's because we share that same gestational environment, the same timing events of when fingerprints form on the fingers, and the same conditions apply to every human being. So although there is variation in our class characteristics, it's really not large enough to determine cohorts based on that alone. But we can make some predictions and assumptions just based on a fingerprint, although you have to look at that blue overlapping graph and realize that, much like a lot of dimorphism between men and women, there is differences at the extremes, and those are quite large, but there's a larger degree of overlap in the majority of the population for various features, and that includes fingerprint patterns. But one of the things it also includes would be, if you look at the highlighted text, ridge density. So in a given area of a finger, if you just look at how many ridges fit into a certain space, women on the average will show a greater density or number of ridges in that area. But by no means would that really assist you in casework, just because such a large overlapping field presents itself, and it wouldn't really be anything that you could use. When it comes to age, this is something where you do see probably more observable features in older individuals' fingerprint And that just has to do with the aging process in general. And just like everything on the body changes, and usually not for the better, our skin and our fingerprints are a little bit less elastic. We get a little bit more wrinkles, more creasing, things of that nature. The ridges themselves do undergo some changes. It doesn't affect whether or not you can identify an old person or an elderly person from a print that they made at a younger age. It just means that you might have a little bit more degree of difficulty, and there's some other things that you have to keep in mind with that. Next question. Couple more seconds. It's all in how you word the question. It's the most accurate answer is the last one. The arrangements are largely unchanged, but blah, 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 blah. And usually any question where you see absolutely 100%, don't choose that answer. It's not going to be good for you. So this is an early study in fingerprints by one of the early pioneers and researchers out of the UK who did a lot of work in India and was quite successful in India adopting the use of fingerprints early on, and it spread throughout the Western Hemisphere as well. And this was an easy thing to do for people that were interested in fingerprints back in those times, where you could record your prints or the prints of a student, and you'd be in contact with that person or yourself over the decades. And as long as you had the time, you could do these longitudinal studies and show that the arrangement of the ridges, although maybe not as pretty and crisp as a certain age and in the younger years, would show that the arrangements themselves were still intact. Now, that's not to say that what I said just previously in one of the other slides, that as we age, there are changes in the skin that take place, and those do have to be taken into account. And with rare exception, do you see any substantial feature altering or being changed through some sort of growth process or breakdown of the skin? They're largely intact. They're just a little bit less legible in many ways. Okay, next question. Okay. Yeah, we're gonna go false on this one. So this is probably to be expected. A lot of primates, just about every primate, old world monkeys, new world monkeys, and the great apes, which include orangutans, gorillas, bonobos, chimpanzees, have rich skin on their hands and feet, as do some other species like koalas, which are not related to the primates. Just through convergent evolution and habitat, there seemed to be environmental pressure that selected for animals with ridges on their skin, seemingly to assist with both grip and fine coordination and texture perception of their fingers and hands. So there's a human hand and a chimpanzee hand. So there's a size difference and a morphological difference of the shape and things like that, but the skin is still the same. So that suggests that between these old world and new world monkeys and great apes that split many millions of years back, that the rich skin of the hands and feet has been a very staple trait among populations that originally came out in arboreal habitat. And it must have been important enough, or at least genetically linked enough, that it's been stable for that many millions of years, which I just find pretty interesting. Okay, let's go to our next question. Hold on, I gotta stop sharing that. There we go. Oops. Next one. Okay. Yeah, I like these lopsided answers. And you're right. It is true you can identify people by their footprints. It's just not something that's commonly collected or seen. Although if you think about which environments, which crime scenes would be more likely to have a footprint, it's probably going to be something like an indoor scene. Probably someone who lives in the residence walking barefoot. You know, but certainly there's a lot of other ways that can happen. All right, so for everybody who got this question correct, which of these pictures is from a finger and which of these is from a foot? Now, I don't have a poll question for this, which I should have, but so once you've made your decision, the correct answer is the footprint is on the left and the fingerprint is on the right. So the ridged skin on your hands and feet are structurally the same. Different patterns might be different in certain regions. Thickness and thinness of the ridges might be a little bit different in certain areas too, but this is also highly dependent on the individual and what they do with their hands or what they do with their feet, whether or not they wear shoes often or don't. But the process of identification of a footprint to a fingerprint is 100% the same. Next question. Okay. Yeah, we're going to go with it's possible, but it's not without its cost. So there's a lot of ways you could do this if you're so inclined, and you probably have a good reason for doing it. And by that point, you're no longer sitting in a university chair. You're probably doing something else with your life. There's many famous cases of this, and every so often, an example of a mutilated fingerprint makes its rounds, and it's usually for reasons where someone has a prior arrest record, and they're trying to get past a certain checkpoint or sorts. This is probably not someone who goes out to burglarize a residence, which is a very common kind of crime. This is probably someone who has something a little bit more severe, and they might have a different job in life at this point, which, you know, usually involves crossing the border with lots of cocaine or something of that nature. So you can chew off your skin like in picture B. You can slice off different parts of your skin and reattach them like in A. You can cut and resuture like in the lower ones. And I'm not sure what the lower left one was. Either way, not a fun time. Each of these will represent themselves differently, though, in a latent print or a rolled fingerprint. So you can see the examples of some of the ones that we saw on the other page and different methods that have been used and tried. Just look outside of what appears to be the injured area, which you can kind of tell without having much training in this. You can tell which part of the finger was the part that received the knife or the injury of sorts. And if you look outside of that, it's a pretty normal looking fingerprint. So what that says is that the fingers, if they leave a print, that area outside of that scarred or injured area is still pretty useful. And that scarred area is also very useful, but just in a different way. These are types of things that in a basic introduction latent print class, we could talk about in greater depth. Next question. Okay. So this is overwhelmingly popular as true. Now, I'm going to go with this is probably fact. It's my personal belief, but we have to understand what this really means and what we're talking about when we say unique. Unique, as it's defined, means of one, and I don't doubt that each of us have our own singular existence at this time, at least. But the problem is in quantity and measurement and in legitimate casework scenarios. So are we saying that fingerprints are unique, or are we saying that a latent print, in other words, a partial representation of someone's skin, is left behind, and oftentimes in a distorted fashion, incomplete fashion? Are those unique? Now, I don't mean that is that one impression that you see the only impression that exists of that thing, but I mean, does the arrangement or those ridges that you see there, could they be very similar or confused with another person's finger impression of a limited amount? And the answer, of course, is to the degree of the evidence that you have. If you only have a little piece of the puzzle to make this judgment on, your accuracy declines. If you have a lot of information, in other words, if you had a big, beautiful fingerprint and you're comparing it to another big, beautiful fingerprint of that person, then you're probably going to fall into the camp that that fingerprint is, of course, going to be unique. But the less of it you have, or in other words, the smaller the sample size that you use to compare, you can't really make those statements. So in latent print work, we stopped making that statement of all the fingerprints are unique, because really it's such a large statement and we don't have the ability to compare all 10 fingers and all 10 toes of all 8 billion people on this earth and all those who have gone before us and might come, to figure out whether or not someone actually has a duplicated fingerprint. Now, you could hold different beliefs the way you want, and certainly the evidence does support that the more friction-rich skin of someone you sample, the more likely you are to be accurate when you attribute to them a similar size impression. Hope that makes sense. So this would be an example of what we call major case prints. Fingerprints and palm prints collected, as the name would suggest, oftentimes with a major case, a homicide, something of that nature, where you collect not just their palm, but the sides of their palm, the sides of their fingers, the joints of the fingers, and the tips of the fingers, to be sure that you've collected all the available friction-rich skin of that person's hands. And then you could be certain when you exclude or rule out a fragment of a print that you actually had all that person's skin to compare to. So there's quite a bit of real estate on your hands and fingers than just the fingertips that you typically see or hear talked about. Only a few more questions. Okay, that was a good spread for answers. This is going to be another one of those, mostly it's one thing. That's mostly false. So how fresh a print is depends on a lot of factors. Personally, I've developed prints that are years old on evidence that's been correctly packaged and preserved. There's been documented cases of prints being developed on decades old material, usually things like papers and things of that nature, where paper is a really good preservative for fingerprints. The one caveat, as far as if you could determine whether something is fresh or not, is whether or not you know that the surface is brand new or relative, or had been cleaned or wiped down relatively recent. An example of this would be, let's say, the windshield of a car. If you just washed it and you find a fingerprint on it the next day, you know that that fingerprint was left there between the time that you washed it and the time that you saw it. So you can establish a brief timeline. There are lots of studies, and this is more in the research realm, of trying to determine, based on the constituents of a fingerprint and the degradation over time, just how long something has been there. But in practical casework for determining latent print age, it's just not something that you can make these assumptions with. Next question. Okay, see what we have. The correct one is, it's unknown unless tested. Now we can, like a lot of these answers, we can make certain assumptions, but oftentimes the true answer lies in not really knowing the answer. You have to think that prints from casework, we don't really know the ground truth. In other words, we don't know how a print got to where it is. There's a lot of contributing factors to that. There's also contributing factors to what gets on your skin to transfer. So imagine your skin is a lot like a rubber stamp that picks up ink and transfers to a piece of paper. Well, you could pick up anything from that stamp really and transfer it. But the friction-rich skin, which is this type of skin that you see on the left, has only one type of sweat gland, and that sweat gland does not produce oils. Other areas of your body, such as forehead, does have glands that produce oils. And so when you touch those parts of your body that produce oils, that is what gets onto your fingers, along with the natural sweats from the friction-rich skin itself. When you transfer all that, it's very possible that you have oil that gets transferred into a latent print. But you don't know that, because in order to determine that, you'd have to actually sample the print. And from the latent print identification side of investigations, that would it would inhibit you from doing your comparison work of those prints. So you pick one or the other, and generally speaking, we're more interested in not what a print is made of, but who made that print. And so that's why we'd rather look at the features of the print and compare it than try to determine what the heck caused, the print itself. There's another nice sweaty picture for you. If you touch an object, you will transfer a print. Okay, I think this might be our last one. I think. It's complicated. Yeah, in a perfect world, at least for me, if you touch an object, you transfer a print. But it's complicated. Let's find out why. So as you see, our chief villain up there, the Witch King of Angmar, he's wearing gloves, metal gloves. So you're not going to transfer a print even though you're touching an object. Also, his sword is a magic sword that burns. So the likelihood of getting a print off of a sword like that is probably not going to be too high. And of course, in the real world, there's a lot of other factors that come into play. So we talk about sweat on the hands transferring to an object. If you don't have much of that stuff to transfer to someone or to something, then you might have partial transfer or hardly any transfer at all. And so it kind of comes down to how much is transferred, what the object is like, and detectability. Do we have the techniques that are sensitive enough to detect very minute amounts of trace elements that come from your skin? And in some cases, yeah, we do. And we do get lots of prints successfully developed on things like paper, metal, glass, plastic, all different kinds of things, styrofoam. But there's so many factors that come into play that, just for instance, something very similar to that burning sword would be a fired cartridge in a gun that gets ejected. So a cartridge that gets cycled through and fired, there's a lot of heat and pressure buildup around that cartridge case, and the latent print residue, being very fragile by nature and resting on the exterior of that surface, is going to be susceptible to destruction during that whole process, let alone when it gets ejected and bounces across the pavement and then later on gets rained on overnight. And so those types of objects hardly ever in my experience see ridge detail developed on them. But there are plenty other objects where you see just a never-ending amount of fingerprints on. So it all depends. There's too many variables that come into play, but you just have to know when you're more likely or less likely based on those variables to expect something. So we say in theory, there's no difference between theory and practice. Well, in practice, there is. So the answer to that one would be it's complicated. Sometimes it's true. That's it. I think we made it a little bit longer than half hour. I apologize for that if you had something to go to. If you want to unmute yourself and ask a question, please feel free. You could type in questions if you have any questions, anything at all.
I would thank you, Dave, for that great lecture. I also would say you're welcome to ask Professor Tate any questions that you might have. And also, if you have any questions about the program in general, the forensics program in general, I can answer that. We also have another one of our faculty members, Dr. Deepika Das, is on the Zoom as well. She teaches our forensic chemistry class as well as our forensic capstone class. Dave, you want me to read questions from the chat? Would that help? Or
okay, I just saw it. Okay. I got a question here. It says, how did I get interested in fingerprints? That's a good question. Well, when I was doing my master's many years ago, one of the things that I had to do to complete my master's was either an internship or a thesis paper. And I decided to seek an internship. At the time, I was very interested in doing crime scene investigation. And so I got latched on to a mid-sized police department out in Connecticut. And unfortunately, during a lot of the hours where I was there, not much of interest was actually going on. All the good stuff happens at night. I lived an hour and a half away. I was an intern. They didn't call me out to go to a crime scene an hour and a half away at night. And I don't blame them for that. But what I did do was hang out with the one-person fingerprint unit. And he's a very nice guy. And I was very, very lucky and appreciative to be able to sit down, and he shared what he did for a job looking at fingerprints and comparing them to fingerprint cards. And it might be my temperament that I just kind of gravitated towards it. I consider it a lot like sitting down and putting together a puzzle. You're not going to have a lot of interaction with a lot of people while you do that, but it's very engaging and it's exciting. But just keep in mind that when you're doing that puzzle that you're putting together, it's a little different. Where this is more like when you go and visit, your grandmother's house and she has a puzzle from 30 years ago and 5 pieces are missing. So you're never guaranteed that you're ever going to find it or complete it. That's a little bit more akin to casework. Okay, lots of questions coming in. Let me see if I can catch up with these. Overlapping prints, is it easy to separate them for identification? It depends. Sometimes if they're, okay, I'm just going to use, if you can see my hands up here. If I have a print that's like really laying on top of the other like that, it's going to be much trickier. If I have one that has a lot on this side, a lot on this side, but they have a little like a Venn diagram kind of in the middle overlaps, well, I can at least use those parts on the end, and I can kind of see what's going on where they intersect. In some cases, it's going to be tolerable to go into those difficult areas and work with overlap. And in many cases, it's extremely troublesome and problematic. All that means is that you really have to lower your confidence values in how you judge whether or not what you're looking at is real or an artifact caused by the distortion that you call overlap. This is actually an area where humans far outperform automation. So if you see fingerprint automated database type stuff on TV, that's very consistently useful in operating the way it does, the way you tell it to work. But once you introduce distortion into your prints, it has a very difficult time in dealing with it, where the human can deal with that stuff very accurately, sometimes quickly, not always quickly, but at least hopefully accurately. Relating to my job, have I ever had to be an expert witness in trial? Okay, so I've been there about 16 years, and I've testified just a little bit over 60 times, mostly because I work for the county and in county court, state court, and I think like once for city and a few times in a federal court. So yeah, it's part of the job. Pretty much anytime you see forensic in front of a title, it should mean that at some point you're involved in criminal matter, which once you get involved in criminal matter, you can be subpoenaed to testify as to what your role in the case was. Okay. Why would someone have their fingerprints in a database before committing a crime? So this is actually the case. You could have your fingerprints in a database for multiple reasons. And you can think about it as being grouped into criminal and civil. Okay, so people who legitimately have had fingerprints taken for job applications, pistol permits, what have you, and people who upon arrest have their fingerprints taken. So for this side of the group, the civil side, those fingerprints, depending on the age and different restrictions that various states might have in place, those are part of the database and are accessible. It's just a matter of whether or not you can use them in a case and whether or not the legal side of it comes into play as far as admissibility and things of that nature. But that would be the reason why someone would have fingerprints in a database. Did I study forensic science in undergrad? I studied human biology in undergrad. I knew I was interested in forensic science as one of the avenues I was going to pursue, the other one being sports therapy, physical therapy. So something along that human biology track, which is essentially what I studied as an undergrad. And it was mainly because the school that I went to for undergrad didn't have a forensic science program. And I really decided on exactly what I want to do, probably about year 3 of all that. And so that's why I pursued my graduate degree. Is there prior knowledge required for a latent print course? An introductory course? No. If it's an introductory course, there's no prior knowledge. I can say that, but I would also recommend that any of the sciences that you pursue, when we start talking about forensic science or fingerprints and things of that nature, we're getting very specific in your interests. It doesn't mean that you shouldn't have a broad science understanding. So what I have noticed is, now again, I'll go back to saying that anyone can take the class, but what I do see is a trend that people that have a bit more of a science background tend to perform better on average. Those who don't and really are fearful of that whole arena, you might have a very strong interest in forensic science, but some key concepts do come in from basic science, be that chemistry, physics, biology. Depending on your discipline, you might get more of one or the other. I tend to introduce more biology concepts in my class than I would some other things. And so I do think it's helpful to have just a good general understanding of that for your own benefit. That'd be my recommendation, but not a requirement. Can forensic science act as pre-law? Doc, I'll hand it over to you.
Yeah, okay.
I don't know
For
if you
the
saw that one.
graduate program, is that the question you're looking at?
It's in general, it just says, can forensic science act as pre-law?
Oh, thank you. Yes, it can. So just a little bit of a background of our program is, at Syracuse University, as an undergraduate, if you take forensic science, it's considered an integrated learning major, which means you have to pair it with a different major. And we typically tell people, if you want to be a forensic scientist, you probably should be pairing it with chemistry or biology. But if you're taking forensic science for a different reason, say you want to go into criminal justice or something like that, you might want to pair it with sociology. And there are a lot of students that do want to go to law school, and they might have psychology as their undergraduate major, or they might have political science or economics or anything really. But they just want to, get a good, they have an undergraduate degree, they plan on going to law school, and they think taking the forensic science program will give them some information to help them when they go to law school. And so we do have students that do that. We also here at Syracuse have a master's program that has different tracks, and one of them is a combined JDMS. So we also have students that are in the law school here that get a combined law degree and master's in forensic science. So students that maybe want to go either into criminal law, or be prosecutors, or civil law, even like DWI cases, you might have forensic toxicology. So we do have students that are actually law students that take graduate level courses with us as well.
Okay, a couple more questions that are probably more for you. For the graduate program, is there a thesis slash research project required prior to graduation, and what would that entail?
So that's a good question. So as I said, we have different graduate tracks. So for the graduate program, we have an advanced laboratory track, which does require a research project, which would be doing research either with someone at the university or in an internship where you're actually developing a question and performing some kind of scientific research on it. You would have to write a research paper and present that in public, at a lecture. We have other tracks. We have a general track that does not require a thesis, although you can do research. We have a medical legal death investigation track that requires an internship in a medical examiner's office, does not require research. And I will say for the undergraduate program, to get the degree, you do have to take a class that's called Capstone in Forensic Science, which is where you'll learn a bunch of different things about the field of forensic science, different careers, different types of organizations within forensic science. There's some guest speakers, but it also involves a project where you have to come up with a research question, and the difference between that and a thesis, it's not as involved as a thesis. And also you don't necessarily have to do a scientific hands-on experiment. You could, develop a problem where you're doing a survey and doing things like that. Or you typically have a mentor that you work with. It's a much smaller, it's done in one semester. So it's a much smaller project.
Okay. Where are popular internships for undergrads studying forensic science?
So that's, yeah, go ahead. You want to go?
Well,
ahead?
I'll just, from experience back when I was in that chair, I would say crime labs and police agencies, by and large. That's where you're going to have to look. And that usually includes medical examiners' offices and things like that. You can try to loosely tie in some other fields that might have some overlapping practical benefit, I think. And so that's where you have to be a little creative, because depending on where you live, whether you're doing your internship from home or while you're in school, you might be in a large metropolitan area or you might not. And also it's going to be very competitive because there's a lot of people like yourself who are seeking that internship. Which is one of the reasons why I ended up at the PD. I ended up for my internship back in the day, is because it was very, very competitive to try to get into the one place that everybody back there wanted to get into. So Doc, if you have anything else to add?
Yeah, I would echo what Dave said. Also, there are, so crime labs again, as he said, you can do an internship at a crime lab locally here, although there's only one crime lab in the Syracuse area. But a lot of our students, do them back home where they live, they stay at home for the summer and they can get an internship at a crime lab or a medical examiner's office or a police department there. We also had a number of undergraduate students and graduate students that have done internships at the FBI. They have an honors internship program, the DoD, the Department of Defense, and we have a connection with the Defense Forensic Science Center, which is basically the Army Crime Lab in Georgia. So some students get internships there. There's a large number of places to do them. However, I will say there's not a large number of internships, so they are competitive. But we do support our students in helping them to find internships if we can, but it's definitely on the student to have to, figure it out on their own and apply on their own. Oh,
Okay,
and I will add, I'm sorry, Dave, I'm just gonna add one other thing. We also have Syracuse University and the forensics program. Also, we work with another program here in the university called the ICCAE, which is the Intelligence Community Center of Academic Excellence. And that's actually, there's only 12 of those in the country, and we're one of them. And this is where all the intelligence units like the FBI, the DoD, the DEA, the ATF, pretty much any three-letter acronym you can think of, they're trying to increase the diversity of the applicant pool for their particular jobs. And so we have a program here where you can join that. And there's speakers that come in that you attend, and they have job fairs and just trying to promote the learning about the different jobs that exist in the intelligence community. And a lot of our students do that and get internships through that as well.
Great. So this is the last question, unless anyone wants to sneak one in. From Vlad, does development in AI make human involvement in this field obsolete? Now, Vlad, you might want to clarify for me. I'm assuming you mean fingerprints, or do you broadly mean forensic science? I'll start answering it from my point of view with fingerprints. Does AI make this field look obsolete for a human? Not at all. And there's a lot of reasons for this. So one is harsh but true, is that the field of fingerprints in the United States is a very slow moving discipline as a whole. I mean, like glacial in advancement. Since I've been there for 16 years, just generally speaking across the country, there's been some improvement in some areas, but largely a lot of areas have been left untouched. And partly this is due to the decentralized structure of agencies across the country that perform fingerprint examinations. What that means is in other countries where it's from top down, where all the procedures and analysis guidelines go from one place and disseminate out through all agencies to perform things the same way. That's not the case with Latent, for instance. So you have some agencies that might be very advanced in how they do things, and other agencies that are not advanced at all and are pretty much stuck where they were 20 years ago. What that means is that there's plenty of room for human involvement because it's not going to be automated anytime soon. There are certain areas that are more automated or lend themselves more to automation than others. Clearly, the automated database searching has been automated for going on through 30 years. It's only getting more efficient. But even those systems still really rely on the human input for all but the best of fingerprints. So like I think I touched on that before. So even that area still is not quite without the human involvement. And then due to more the legal admissibility side of the issue, even with an automated database produced identification, you still have to have the individual go and testify as to the case, the fingerprint, what they did with the automated search. They have to testify to a jury about that. There are probably a few areas where different technology can assist, but as far as supplantation of the human by AI, it's a long way off. And there's so many facets of investigation of just from the evidence side of things that it's going to be a useful tool in a lot of areas, but it's going to be a long time, if ever, before a human can be totally ejected from the formula.
I'll just add one thing to that as well, and that we actually have a class here called computational forensics, which is a little bit of that. It's a little bit about applying different programming to the field of forensics and a little bit about AI. And some of our students have done their projects, their capstone projects on trying to look at AI to help determine cause of death in pathology reports, or looking at AI to help determine stutter rates and in DNA PCR amplification. So I think it does, there are some applications to it, and certainly it's an interesting field right now to see how AI is being applied to the field of forensics.
Right. I'll just I'll append one more thing on for latent prints. You could break down any task you do with from fingerprint recovery, that is photography, development with powder or chemicals, light sources, capturing that, preserving it, analyzing it, comparing it, searching it in the database if you need to, wrapping all that up and bringing it to court somehow. Any point in that flow where you have very easy yes or no types of answers to your questions, it lends itself to a part of automation. But anytime you have an element of subjectivity that needs expertise, in other words, experience with difficult situations or complex situations, that's going to be where AI has a really rough time. And it's not as simple as just writing the program and having it take over. Although there's definitely some areas where it's going to be very beneficial, and one would be the very important one of at what point do you make a decision to identify the latent print from the crime scene to a certain person, instead of saying, I'm not sure it's this person or it's not this person, saying this is that person's print. In other words, when you make that decision, right now it's subjectively determined by the human examiner. And we know that we're not infallible. So the closer we can get to an accurate algorithm that can model fingerprint features in their arrangement with the compared known print that you're looking at, and come up with the correct decision 100% of the time, or at least push towards that direction of higher and higher degrees of accuracy. That's where the algorithms are most beneficial, and they're already being employed by some agencies. It used to be taboo to talk about that about a decade ago, but there are some private entities as well as public that are starting to roll those out, but they're at this point used in conjunction as a tool to aid in the decision-making capability of the human examiner. I do foresee, though, probably in the next decade or so, depending on where you are, that'll be more and more important in the process.
Great. Are there any other questions before we end the session? Well, we thank you all for joining us. I thank you, Professor Tate, for this great lecture, and thank you everyone for joining us. I put our forensics email in the chat. If you have any questions, please feel free to email us at any time. We'd be happy to answer any questions you might have.